Alright, this is 2012, May 2012. Temperature, architecture, and organizations. Alright, a certain circuit has two inputs, x and y. The output is given as the Boolean function f, where f is equal to x, y prime plus x prime y. Give the truth table for the circuit. Alright, the truth table would be, so we have x and y, so x and y, normal layout 0 0 0 1 1 0 1 1. Those are always your 4 possible inputs. Alright, so we have to figure out what is x and not y. Okay, so I'll go and put not y, which is basically y, and like that. So not y will be 1 0 0 0, and then we'll do the not x, which will be 1 1 0 0, and then we have to do the x not y. So this is and x is 0, not y is 1. So we basically comparing this here with that here, and 0 and 0 0, 1 and 0 0. Yep, that should be the x not y. And then we continue our process, and then we'll have the not x y. So that's an and again. So dealing with the not x, which is here, and the normal y, which is there. So 1 and 0 will be 0, 1 and 1 will be 1, 1 and 0 will be 0, 1 and 0 will be 0. So we get in there, and now we have to OR these two. So it will be x not y, or not x y. So 0 or 0 will be 0, 1 or 0 will be 1, 0 or 0 will be 0, 0 will be 0. Oh shucks, yeah, my bad. Alright, so let's rewind. This one here is supposed to be our 1. My bad. Alright, so if this is supposed to be our 1, then that changes the whole thing. So let's go back now and do the x not y, 0 or 1. No, that'll still come out to be a 0. X or, yeah, x and not y will still be a 0. Yeah, so I don't think it's changing anything. It's just I made a mistake there with the not y. Malia, so you had your hand up before that. That was that same thing I was trying to point out. Oh, it was Jasmine and okay, cool. Alright, so that's the answer for that. Now give the truth table for the circuit using only primary logic gates. So we could work it backwards, which is the plus sign first, which will be represented here. That'll get the output of f. What comes into it will be something x and y, but we have some not taking place. So they are leading back to ands, and the two ands are going to be there, and then you're going to have the nuts that are going to invert them. So the first one is normal x, so normal x will just come straight into here, cool. And then not y, so we'll take our not y from here, send the not in there, and then we'll take this guy right there. That'll give me the not y. And then the next one I need to get in is not x, so I have to take from there, get the x to be knotted, and drop it inside there, and then normal y will come from there. So that will be our diagram there. 6 marks for the wait, I didn't go through the marks. Alright, let me see where these marks will come from. The truth table for the circuits, I think they will only give you marks just for having the correct thing at the end. So that'll be 1, 2, 3, 4. The 6 marks here, you get a mark for each logic gate. 1, 2, 3, 4, 5, and then I don't know, a mark for the lines, for the correct lines. That is all I could think of. Unless they're giving you a mark for using the NOT gate properly, but I can't be sure. So, the best I could tell you. Alright, good. Next. Draw clearly labeled block diagram of a 4-to-1 multiplexer. Okay, a 4-to-1 multiplexer will look like a box with 4 lines, 1, 2, 3, 4. This will be input 0, this will be input 1, input 2, and input 3. And there are 1 output. And then you're going to have S1 and S0. Selection 1 and selection 0. And the selections will determine which one of them will get chosen. And the name in this multiplexer, 4 marks. Why you get 4 marks? Well, I'll tell you. You get 4 marks because you get 1 mark for putting the inputs, 1 mark for naming the box thing, or 1 X mark for the selection. And the 4th mark, I don't know. I'm not sure. They probably will give you an X mark for labeling the inputs 0 to 3. Yeah, probably. That's my guess, but I'm not sure. Alright, so in a security system, 4 sensors must transmit data to a single line for alarm notification. Each sensor transmits data for 1 second. Explain how a multiplexer can be used for the purpose described above and discuss how data from each sensor is transmitted through the alarm notification line. Alright, so we had to write a lot here. Can I fit it there, right? Yeah, I'll have to fit it at the bottom. Unless I have space on the side. No, do I have space here? Space here? No, I don't have space here. Okay, I could fit it inside here. Alright, so we want to know, explain how a multiplexer can be used for the purpose described above and discuss how data from each sensor is transmitted through the alarm notification. 6 marks. So the alarm system, 4 sensors come in. So you're going to say, first point is each input is linked to a different part of the system. Example, input 0 would be a door and input 1 would be a window. Right, so that's showing that each one of them linked. When the sensor is triggered, it sends an input into the system. Right, good. Good. The selection switch now will change from 0 to 3 every 1 second. And if the input sensor has been triggered, the signal would go to the alarm output. Okay. So where would 6 marks be inside here? Well, clearly they're checking to see if you understand how a multiplexer works. And how the multiplexer works is that each input will be linked to a different part of the system. That's 1 mark. Showing that each input will be linked, input 1 and 2, I would say that's 1 mark there also. Then you would say when the sensor is triggered, it sends an input into the system. Cool. And now we have to show how the multiplexer is going to be used to transmit the signal now. The selection switch will change from 0 to 3. That's definitely one mark because you have to know that it's going to change from 0, 0, 0, 1, 0, 2, 0, 3. And every 1 second, it's going to check. And if it checks in that second and there is an input signal, then the alarm will go off. So that would basically be the marks bit there. Any questions? Did you have something like that? Or did you have something close to that? You will only get like 3 marks because you have to show you understand the technical part of a multiplexer and how it will apply to life here. Alright, so if everybody's okay with that, or no. Alright, next one is showing or working, find the largest and smallest integers that could be stored in 4 bits when sign and magnitude is used. Okay, well, this kind of straightforward. 4 bits, you have 0, 0, 0, 0, which is representation of the number 0. And then the highest number that you could represent, sorry, that is not the highest number, sorry, my bad. The smallest number that I could represent is 1, 1, 1, 1. 1, 1, 1, 1 means this is negative because of this sign here. That means it's negative. And then the negative, the number there is 7. So negative 7 is the lowest. And then the highest number that I could represent would be 0, 1, 1, 1 because it'll be positive 7. Because this here will be positive. So basically negative 7 all the way up to positive 7. That's when you use sign and magnitude because you're just taking the first bit as the sign and then the other 3 digits you're just calculating the normal binary value, the normal decimal value. So shouldn't be a problem there. Alright, good. Alright, consider the following floating point representation. So we have a 1-bit sign, a 3-bit exponent, and a 5-bit mantissa. So the sign is negative, the exponent is 0, 1, 1, which is 3, and then the mantissa now is 0, 0, 0, 1, 1. So we're going to move this forward 3 points. So we're going 1, 2, 3. So we get 0.11, which converts to, this is a half and that is a quarter. So a half plus a quarter is 3/4, so it'll be 0.75. Negative 0.75. So the answer will be negative 0.75. Clear? Alright, everybody got that. Cool. Okay, explain what is meant by the term instruction set. Anybody want to answer that for me? The basic amount / number of commands that a CPU can understand. Alright, that's totally correct. Basic number of commands and understand, that'll be the 2 marks there. Briefly describe 3 types of instructions that are typically included in an instruction set. Somehow I feel like we do this question already. This was in our previous past paper. Okay. Alright, what are the types of instructions? Arithmetic and logic, data manipulation, and then control / branch. So arithmetic and logic would be like add, sub, data manipulation will be move, and control and branch will be like jump. So they say briefly describe or give examples. Okay, these are examples. The actual description will be like mathematical commands, movement in memory, and jump will be choosing commands. I guess once you have the example, you should be okay with it, because to describe these things, it's kind of weird because you will have to use back the same word because it has controller branch in it. So you'll write some sort of explanation, but the example is what will seal your mark. So keep that in mind. Explain how cache memory can increase the efficiency of data retrieval. You basically have 3 points, so it should be the first one. Cache memory moves at the same speed as the CPU, and the more you have, the more instructions the CPU can fetch to be calculated/executed. Something like that, yeah. That should be okay. So cache memory moves at the same speed. You clearly want to say that it's the same speed as one mark. It moves at the same speed as the CPU. The more you have, the more instructions you'll be able to fetch, and therefore the calculations will go up. That is, yeah, that's a solid answer there. Alright, number 3. Distinguish between the opcode and operands of an instruction. Well, opcode is the task or function to be carried out, and the operand would be the data or memory location. Task is applied to, yeah. Anything to that effect, you should be okay. Yeah, 2 marks, so didn't really want it to kill it too much. Alright, 2 typical instruction formats are 1 address and 2 address. Describe how the operands are obtained in each case and specify where the results are stored. Alright, so 1 address. The operands are obtained from the register, and the result is stored in the accumulator. 2 address. The operands are obtained from the memory or registers, and the result is stored in memory or one of the registers. 3 marks for each because you're looking at one, you're showing that you obtain it from the register, and the operands obtained from registers, and then all the results are stored in the accumulator. So a result is some sort of calculation. So you get it from the register, they do some calculation, you store it in the accumulator. This one is obtained from memory or the registers. A result takes place, but the answer is stored back in one of the registers or the memory. So that should sort of that. Any questions? Did you all have something like that? Basically, yeah, alright. Alright, explain how a hard disk differs from RAM in terms of access method and access speed. A hard disk access method. Hard disk is sequential. A hard disk is index sequential. Okay, so it's either sequential / index sequential, whereas RAM is direct / random. Access speed for a hard drive is slow, and for RAM is fast. 3 marks. Yeah, I really don't think they want too much more than that, even though it's an explained question. They're really checking to see if you can check and see that the hard drive is a lot slower. And how do you access data from a hard drive? Usually sequential or index sequential. And RAM is very direct. Alright, explain how RAM differs from a CDR in terms of volatility and storage. Alright, RAM, CDR. RAM volatility is high volatility, CDR low. Storage of RAM is lower, CDR is higher. I'm not too sure if they want a sentence, but I don't think a sentence will be necessary because it's 4 things they basically put in and it's 3 marks. So usually I would guess that the lower and the higher part is 1 mark and then the higher and the lower. Just by knowing it will be better. I'm not too sure if they wanted any more words than that.